So we're asked to find the velocity and acceleration functions. This is telling us position. So the first derivative of the position function is the velocity function. We want s prime. And so using our power rule when evaluating derivatives and using the fact that the derivative is like a linear operator, you can take a derivative of each individual term. We can start with derivative of 2t to the third. 3 comes down and multiplies, and then it gets reduced by 1. The 2 comes down and multiplies, and then the power gets reduced by 1. And then we got minus 36t. The 1 comes down and multiplies. And there's our velocity function. 6t squared minus 6t minus 36. Acceleration is the second derivative of the position function. So you just need to take a derivative of the derivative. So a derivative of the velocity. So the 2 comes down and multiplies. Power gets reduced by 1. The 1 power comes down and multiplies, and the power gets reduced by 1. And the derivative of t to the first is t to the 0 power, so that's just a 1. And the next part is to determine the time intervals when the object is slowing down or speeding up. So just remember what these tell us. This tells us like velocity. If we get a positive number in here, then we're going forward on the horizontal line. If we get a negative number, then we're backing up. It's like a car goes forward or a car back is in reverse. And then this tells us how fast our velocities are changing. Okay, so it's acceleration. It's telling you whether you're speeding up or slowing down, but they both have to be considered when you're thinking about whether we're speeding up or slowing down. Okay, because you can be speeding up going backwards, right? So if velocity is negative, we're going backwards. And if acceleration is negative, that means the velocity is decreasing. If you've already got a negative velocity, decreasing means it's becoming more steep because you're getting further back in the negatives. So we're speeding up. Let me see where I can type this. We are speeding up if s prime of t is less than 0 and s prime prime of t is less than 0. Or we're speeding up if s prime of t is greater than 0 and s prime of t is greater than 0. Because this is the other case. This means that we're going forward with a positive velocity. And this means the slopes are increasing. So we're speeding up. We're going forward at a faster and faster rate. And then we're slowing down if the opposite's true. If the derivative is negative and s prime prime of t is positive. In that situation, here I can write that out. Slowing down if s prime of t is negative and s prime prime of t is positive. Because what this says is that, hey, you're slowing down. You got like a -5 for a slope, but your slopes are increasing. So the next step might be -4, -3, -2. You're backing up, but at a slower and slower rate. And then here's the other case. We're slowing down if s prime of t is greater than 0. This means we're going forward, but the rate at which we're going forward is decreasing. Okay. So if both the first and the second derivative are the same, means we're speeding up. If the first derivative and the second derivative are not the same, then we're slowing down. So we want to find out all the places where the first derivative and the second derivative are positive and negative. And luckily, it's not too bad. Okay, this first function is quadratic. You could graph it in Desmos, or you could solve it. You can set it equal to 0. We got to factor both sides. Factor a 6 out of everything. And then you can factor it out of 6. Now I can factor this like a trinomial, like we've done in other classes. Okay, remember the goal is to find two numbers that multiply to be -6 and add up to be -1. That pair of numbers is a -3 and a +2. Just a refresher on factoring trinomials. And then if you set each piece equal to 0, you get t equals 3 and t equals -2 as solutions. So we can ignore the -2 because that's backwards in time, and we can't go backwards in time, right? So t equals 3 is the only potential place where this could switch directions. So like let's plug in 0 in for t, when we're dealing with velocity, and let's see if it's positive or negative. Oh, I'm plugging in 0. So if I plug 0 into the derivative, I'm going to get out negative 36. That means we're going backwards when we first start off our movement on this line. And that means every other point in here is also going to be negative. You could try t equals 1, t equals 2. You'll find that those are negative as well. Because the only place where we could switch directions are when it's quadratic. The only place you can switch directions is when you get to the 0 places, like t equals 3. So this is all negative for the first derivative. I'll make a note. That's negative for the first derivative. And it's probably going to switch to positive, but let's just check to make sure. Let's try plugging in t equals 4 to the first derivative. And if you do that, I don't know how to make that go. Okay, there we go. So I'm plugging in 4 into the first derivative. The first term we get 96. Subtract 24 from 96, subtract 36, and we get a positive number. Plug in t equals 4, I get out positive 36. So that means we're moving forward. The first derivative is positive over here. Okay, and then we want to do the same thing with the second derivative. We want to find out where the second derivative is positive and negative. And I'll draw it below the number line so we can easily distinguish between them. Second derivative is linear, right? It's y equals mx plus b here. It's a straight line. So we could set it equal to 0 just like we did before to find out where that line crosses the x-axis. If you solve that equation, you'll get t equals 1/2. Okay, so 1/2 is somewhere over here. That's where it's going to switch directions. And then we could plug in, like if you plug in 0 in for the second derivative to test out a point, plug in 0 into the second derivative, you get negative 6. So we are negative for the second derivative over here. And then you're going to find that we're positive to the right. And these points, you can pick whatever you want. Anything to the left of 1/2, anything to the right of 1/2. I just picked out 0 and 1 because they seemed easiest. But because that's where it crosses the x-axis, that means everything else is going to follow suit to the right. If I plug in 1 in for t, 12 times 1 is 12. 12 minus 6 is 6. It's a positive number, so that means everything to the right of 1/2 is going to be positive. Okay, so now that we have an idea of the values for the derivative in the second derivative, we can use these rules. Look, they're both negative between 0 and 1/2. So using those rules I discussed, if they're both negative, then it's speeding up. So it's speeding up between 0 and 1/2. I just want to see if they want decimals. Speeding up because both the derivatives match. Between 1/2 and 3, the derivative is negative and the second derivative is positive. So they don't agree. They're opposites. That's where we said it's slowing down. So between 1/2 and 3, it's slowing down. But then look, they both match again to the right of 3. From 3 to infinity, here we need the union symbol. So you need to click that union button in set in WebAssign. I think it's under set. But get union, and then it's 3 to infinity, where it's speeding up.